Welcome to this overview of VR and AR gamified learning, where we explore how immersive technologies and game design can transform education. In this presentation, I will summarize evidence, design principles, technical challenges, and practical steps for scaling effective, equitable, immersive learning experiences, with examples across general education, language learning, professional training, and the emerging metaverse. Here we summarize the evidence and directions from a comprehensive review showing gains in engagement, motivation, and retention across domains while highlighting limits and research gaps. The review covers general education, language learning, professional training, and metaverse work, notes promising outcomes but flags technology constraints, scarce longitudinal data, and the need for standardized assessments and scalable collaboration models. This page explains how immersive tech paired with gamification changes learning by breaking classroom boundaries, boosting motivation with points and badges, and showing proven applications in STEM and language learning. It also flags the main challenges: integrating pedagogy, ensuring equitable access, and aligning immersive experiences with instructional goals so gamified elements truly support learning rather than distract from it. In this introduction, we frame opportunity, evidence gaps, and the review's aim. VR and AR gamification can boost motivation and reduce training costs through immersive experiences, but long-term retention and behavioral change remain understudied. Diverse methods and non-standard metrics limit broad conclusions, so the review synthesizes best practices to guide educators, researchers, and policymakers toward effective, equitable adoption. Our review followed a Prisma-aligned protocol across 6 major databases plus Google Scholar, combining VR, AR, and gamification search terms while excluding reviews to focus on empirical work. Analysis centered on 5 key dimensions: general education, language learning, gamification alone, professional training, and metaverse applications, with the aim of capturing comprehensive, multidisciplinary empirical insights for practice and future research. The inclusion criteria limited analysis to empirical studies of VR, AR gamified learning published in English, reducing an initial pool of hundreds of records to a smaller set of in-depth studies. Non-empirical pieces, duplicates, and works without gamification were excluded, and a Google Scholar cross-check helped reduce database bias, although small samples and contextual limits affect generalizability of findings. Research trends show a publication surge after 2020, with a peak around 2022 and growing metaverse interest since then. General education dominates the literature, while professional training remains underexplored despite clear potential. Early foundational VR, AR studies evolved toward more sophisticated gamification and metaverse research, and gamification emerged as its own research stream deserving focused design and evaluation. Here we highlight immersive VR and AR for engaged learning, emphasizing mobile-first, learner-created experiences and gamified feedback loops that boost motivation and contextual learning. These tools work best for spatial and experiential subjects like science and history, but key barriers remain, including device compatibility, network needs, and ensuring instructional alignment with learning objectives and assessments. The taxonomy of VR and AR in general education centers on mobile-focused learning and platform dominance, where ubiquitous smartphones and tablets enable real-world augmentation and learner-generated content. Engagement and relevance are core features, while underexplored areas include adaptive classroom systems, VR classrooms, and scalable collaboration opportunities that research should target to broaden impact and accessibility. This page outlines key barriers and research directions to enable scalable adoption. Technical issues like device compatibility and network reliability, curriculum alignment to map immersive tasks to learning goals and assessments, scalable implementation models for diverse resource settings, long-term impact evaluation to measure sustained benefits, and equity-focused solutions to maximize access for low-resource learners. Immersive language learning leverages interactive, contextual environments to reduce limited practice and deepen cultural understanding, while VR avatars and simulated dialogues lower communication anxiety and enable safe speaking practice. Spatially anchored AR supports vocabulary retention through word-object links, and virtual immersion exposes learners to unfamiliar settings that enhance cultural competence and contextual vocabulary use. This taxonomy maps language learning goals to XR technology and interaction styles. Vocabulary gains through immersive game-based VR and AR markers with embodied prompts, speaking skills fostered by social VR roleplay, cultural learning enabled by guided VR exploration and location-triggered content, and general comparisons showing VR's holistic synthesis versus AR's targeted practical support for specific tasks. Designing effective VR and AR language learning means scaffolding difficulty to support incremental skill building, balancing cognitive load so immersion doesn't distract, and sustaining social interaction through multiplayer or cooperative tools for authentic communication practice. Thoughtful design reinforces engagement and incremental skill growth while preserving opportunities for real-world language use and peer feedback. For aircraft maintenance training and similar technical fields, gamification adds game design elements that enhance participation and reduce cognitive load, while AR and VR interactions engage learners through virtual practice. Effective systems lower operational cost, track progress and achievements, and emphasize meaningful milestones tied to real-world relevance to avoid superficial or distracting gamified mechanics. The gamification taxonomy links training domains to motivational theory. Interactive procedural training supports competence through step-by-step simulation. Achievement systems like points and badges foster autonomy and measurable growth. Social and competitive elements tap relatedness and extrinsic motivators, and immersive integration ties tasks to real-world relevance to enhance intrinsic motivation and learning transfer. Key technical priorities for gamified deployments include platform stability to support complex virtual interactions, an intuitive user interface for seamless flow, hardware scaling to ensure consistency across setups, and cross-team collaboration between educators, designers, and developers. Overall, implementation should prioritize stability, clarity of UX, and hardware compatibility to enable reliable, scalable learning systems. VR and AR offer immersive, safe, and cost-effective alternatives for hands-on learning, especially when mobile mixed reality merges physical and digital practice with immediate, gamified feedback. These systems support learners' needs for competence, autonomy, and relatedness, and prepare the workforce for evolving demands, though they should complement rather than replace authentic, instructor-led training. In construction education, VR and AR function as complementary modalities that provide hands-on simulated practice, scenario variability, and authenticity aligned with industry safety and machinery standards. These tools can enhance readiness and facilitate skill transfer, but effective implementation requires instructional supports to bridge virtual scenarios and real-world procedures and standards. Professional deployment faces technical and logistical challenges such as integrating hardware, software, and networks reliably, ensuring device portability and battery life for field use, delivering clear UI and consistent system reliability, and building iterative co-design with educators and industry experts while conducting cost-benefit analyses that account for diverse learner access and contexts. The metaverse promises persistent virtual spaces that sustain learner identities and continuous knowledge ecosystems, enabling real-time collaboration across spatial and temporal limits and connecting experiences across sessions. While offering new instructional opportunities to rethink teaching strategies, the metaverse must preserve inclusivity, academic standards, and governance structures to avoid widening inequities or undermining learning integrity. This taxonomy differentiates metaverse educational applications, collaborative learning through virtual maker spaces and cross-institution projects, social learning with avatar-mediated interaction and digital identities, and experiential learning via simulated professional environments and role play. Primary challenges include scalability, moderation, privacy norms, and fidelity for valid assessment and transfer. Adopting metaverse tools faces technical and educational barriers. High compute and low latency networks limit access, unequal device and bandwidth availability create educational inequality, specialist skills like 3D modeling are needed, new pedagogical duties around digital identity and moderation arise, and curriculum creators face steep learning curves adapting to immersive formats. Assessment and governance must address the gap where traditional tests miss collaborative, hands-on metaverse learning by combining multimodal assessment, automated analytics plus peer and instructor evaluation, with strong governance to moderate content and uphold academic integrity. Building digital literacy for ethical engagement and targeted readiness programs will support responsible, valid metaverse learning environments. Gamified VR and AR drive outcomes by boosting engagement, motivation, and retention when designs align with embodied cognition and self-determination theory, supporting physical interaction and spatial cognition while meeting needs for competence and relatedness. Success depends on cross-disciplinary collaboration among educators, designers, and technologists to align technical affordances with social and learning goals. Practical actions for educators and policymakers include training educators in facilitation and technical use, aligning curriculum to learning outcomes and assessments, ensuring equitable access through affordable AR devices and targeted distribution, adopting adaptive frameworks with iterative refinements, and prioritizing policy support for funding, infrastructure, and long-term maintenance to scale impact responsibly. Key research limitations to consider are the prevalence of small-scale short-term studies that limit generalizability, variable and non-standardized assessment measures that impede comparisons, potential publication bias, inflating positive effects, and rapid technology evolution that can date findings quickly. The review's English peer-reviewed focus may also omit regional or industry studies, so interpret results cautiously. Future research should prioritize longitudinal studies on skill retention and transfer, comparative designs to identify optimal VR, AR, and gamification mixes, and exploration of AI personalization for adaptive instruction. Researchers also need to address ethical data practices and privacy in immersive settings, develop standardized assessment frameworks, and investigate metaverse scalability, governance, and credentialing models. To conclude, VR and AR gamified learning show evidence-backed gains in engagement and outcomes and can scale when pedagogy, equity, and ethics are aligned. Persistent barriers include insufficient educator preparation, curricular incoherence, and unequal access, so the path forward requires longitudinal evidence, ethical inclusive design, and alignment of technology with pedagogy to democratize the benefits of immersive learning.